Okay, working our way through the homework 7 key on problem 3. And before I get too far away from problem 2, I should say when you take the curl, if you're going to go through and try the other approach to getting I using j.ds, taking the curl of h, remember this h has only a phi hat component. I left that off when I was writing where you take the curl. And you should have that in there because you need that to set up your curl. You have to keep track of which component of h goes where in that expression on your equation sheet. Okay, on to problem 3 on homework 7. That one is a recycle and plug and chug solution. You don't necessarily have to remember this solution for the magnetic field due to the current segment, but for questions that might be multiple choice, it's important to remember how we got that by integrating up and let me see if I can scroll over onto there, integrating up the expression for the current, or for the magnetic field from currents that form your wire segment. So we had to look for all the currents along DL, which went from like A to B along this wire segment, wasn't infinitely long, do cross product with how far away and what direction. It was that distance from that bit of current to you at the observer spot. Notice I didn't put the unit vector here. This is from your equation sheet on the test, so you'll be able to refer to it. And when you have big R up here, okay, you have to put R cubed down here. Alternatively, you could put little r hat unit vector pointing from the current source to you, and then put big R squared. It's just distance squared. Same thing as in Coulomb's law. Okay, but back to it. We already did that when we were in problem 3 on homework 7. We got this nice solution, and this is the one where we want to take that answer, and I hope to see a lot of people doing the right-hand rule. So in the key, we've written this down. Thumb goes along the current, and we're talking about just segment 1 right now. Then your fingers point in the direction of the magnetic field. And when you're looking at the plane, and you got the challenge of finding the total magnetic field at the center spot, and the wire's in the same plane, that magnetic field is coming right out of the page at us. Okay, and you can look at this and you can spin it and you say, well, the contribution from each segment, that's always going to be out of the page. It's just going to add up. You can superpose the solution. You can always do that. Get the magnetic field from one piece of current, get it from the other, get it from the other, get it from the other. It's easy to do if you already know and have integrated up a solution for a certain thing, like a loop or a wire segment. And you can build that out of these kind of primitive solutions. So we're doing that in this illustration in the homework 7 key. Okay, the main take-home message here is the principle of superposition. Find the magnetic field from one bit of current, and then find it from the other, and just map those solutions on.